Okay, this is number 50 we're doing. We're in stoichiometry. Now let me just say something about stoichiometry, and it's just simply and solely and specifically mole ratios. That's all it is. It's all related to mole ratios. Now, from the mole ratio, you can go anywhere. You can go into mass ratios. You can go into volume ratios. You can go into number of particle ratios. Clear? But it's all mole ratios. When I did problem 45 yesterday, it was all ratios. There were 4 separate problems in problem 45, and it's been posted, and it's all mole ratios. 4 separate problems on mole ratios. Clear? Excuse me? I can't hear a word you're saying.
What is the name of the video?
It's, I don't know, it's number 45. Okay, you'll see it on Haiku. Okay, now. Right, so the problem 50 reads, lithium nitride reacts with water to form ammonia and aqueous lithium hydroxide. If you're going to be an IB student, oftentimes in chemistry, these problems can be very important just in terms of the little things they tell you, because you're going to see the problems again. A lot of these reactions are actually famous for whatever reason. Not every one of them, but many of them are. So you may want to make notes, mental note, and it's not hard to do. You just simply, have you ever gone through a day and nothing's memorable? And then somebody tells you about a movie, right? And they say it's really good, and they tell you a little story about the movie, right? Yes? And then all of a sudden, the next day, which was very similar to the day that just ended, the next day you're seeing posters on buses, you're seeing posters on buildings, you're seeing commercials, all of a sudden you're seeing things about the movie that the friend just told you, right? Yes. Yeah? Well, were those signs there yesterday? Yes. Yeah, they were, but what happened? You didn't notice them, right? So I'm simply telling you to notice the problems. Notice them, because some of them are very famous. Clear? It's just some advice. That's all it is. Okay, now. Lithium nitride reacts with water to form ammonia and aqueous lithium hydroxide. Lithium nitride plus water, solid, liquid, ammonia gas, and lithium hydroxide, which is aqueous, which is going to be in here. Remember, the group 1 metal salts or metal hydroxides or really metal anything are very strongly soluble, dissociable. Understood? In water. Yes? Okay. Now, it says, the problem reads, this is the problem. What mass of water is needed to react with 32.9 grams of lithium nitride? 39 point what?
32.9.
39.2?
32.9.
Sorry, it's my dyslexia again. 32.9?
Yes.
32.9 grams of this. And we're looking for how much water is needed to react, correct? So we're only comparing these two things so far, right? So let's do the stoichiometric masses. What's the mass of lithium? What's the mass number? Use mass numbers, just easier. I use the mass numbers. So if you want to get a number on your exam that's close to my answer, use mass numbers. Understood? Yes? Rounded to whole numbers, yes? So what's lithium? 7, right?
Yes.
So that's going to be 21 plus 14 is 35?
Yeah, 34.7. So 35 is fine.
What was I saying about mass numbers just a moment ago?
Mass numbers.
So what? So what is it? 35. And 3 times 18 is what? 4, 2, 5, 5, 4, 54? Yep. Is that right? Yep. So what's the ratio going to be? It's going to be lithium nitride is to water, correct? As 35 is to 54, which 32.9 is to x. Easy? Yes? Aaron, you look stunned. You look stunned. Are you stunned? Did I do something wrong?
No.
You're just stunned. That's okay. That's okay. The dead parrot sketch. It's not stunned. It's not dead. It's stunned. Yes, what is it? What's the answer?
50.76.
50. So x equals 50.76. Is that what you're suggesting?
Yes.
Yes? 51. Is that all right?
Okay.
Is that all right? So 51. Right? Is that okay? Yes? Now I haven't left a lot of room to do calculations. So let me get rid of this. Is that okay? Simple mass ratio, right? Yes? Okay. Okay, now, this is in 3 parts. This is in 3 parts. Kidding. 3 parts, okay? Now, it says when the above reaction takes place, how many molecules of ammonia are produced? How many molecules of ammonia are produced? In order to find the number of molecules, what do we have to know? We have to know the number of what? Aaron, did you just say moles? Quite spontaneously? That was excellent. Okay? So you were just stunned, momentarily stunned. Okay? So yeah, you want to convert to moles. Okay, the only problem is we need to know how many moles, right? Yes? So we need to convert, we can convert this to moles, right? Instead of doing a mass, because isn't this 1 to 1? Isn't it? So if I know the number of moles, so what is 32.9 divided by 35? Isn't that the number of moles? Am I going too fast? Right? So 32 divided by 35, I'm not even going to write it on the board. It's such a simple equation. Yes?
92.368. Yeah, 30. Oh, never mind. I don't know if you know.
What are you looking at?
That's a calculator because I can't.
Oh, you have a calculator on your computer?
Yes.
Is that what they're calling video games these days, calculators? I'm kidding. He's turning around his computer. Okay, so what is 32.9 divided by 35? It's not a percentage. Yes?
0.91.
0.91? Okay, good. So this is 0.91, right? 0.91?
0.94.
0.94?
I got point.
The Canadian team has made a mistake.
No, 32 divided by 35.
32.9 divided by 35.
39.4.
32.9 divided by 35. 0.94. Excellent. The Canadian team gets some compassionate points for acknowledging their mistakes so quickly. Excellent. Well done. Excellent. All right, now, so if this is 0.94, this is 0.94, correct?
Correct.
So how many particles are there in a mole? You don't know? I'm stunned. 6.02 times 10 to the 23rd particles in 1 mole. You knew that, right? Yeah, you just kind of like momentarily forgot. Stunned is a stun thing. Okay. So how would I determine the number of ammonia molecules in 0.91 moles? Wouldn't I multiply 0.91 times?
0.94.
I'm sorry, sorry. The American team has just made a mistake. So 0.94 times 6.02 times 10 to the 23rd. What do we got? 0.94, right? Don't you multiply it? What's 0.94 of 6.02 times 10 to the 23rd? I still remember that from when I first learned multiplication in like 3rd grade. Of means multiplication, right?
5.66 times 10 to the 20.
Yeah, does that come out? 5.66?
Yes.
Yeah.
Does that come out on the thing? Yes, excellent. All right, yes or no? You got it? Easy? Easy? Yes.
The back of the book says something different.
And what does the back of the book say?
5.71 times 10 to the 23rd.
Well, that's round-off error. The book is probably using atomic weights. We're using mass numbers.
Okay. Fair enough.
Atomic mass, atomic weight, and they're using more decimal places, and the book has no life, okay? Do you want to be a book, or do you want to be a person?
A book.
Yeah,
We'll hear if he doesn't.
okay, really good. Okay, I'll remember that when you're, like, turning down your invitations to go to Sorbonne, or saying that he's really a book, he doesn't need to go to college. Okay, that's fine. Okay, excellent. Now, so there. Okay, now, C says, shall I erase everything here? I think we may be getting into some new territory here. It says, calculate the number of grams of lithium nitride that must be added to an excess of water to produce 15 liters of ammonia. So I want to make 15 liters of ammonia. This is going to be in excess. Is that spelled right?
Yeah.
Okay, all right. All right, good. I'm actually a very good speller. If you give me a word, just writing it, I have a hard time writing it and spelling it, yeah. So, oh, I know, the old dyslexia excuse. I've heard that before. So, what would be, how would you do that? I want to know what mass of this, is that what it says? It says, calculate the number of grams. Okay, so I want to know how many grams of this will produce this amount of ammonia. We can do this in at least two ways. What two ways? Anybody want to tell me what two ways? Put on their thinking cap. Be outrageous. Be crazy. Be wonderful. Be all you can be. Be something. Nobody? No takers? I feel like turning the camera around and showing the world the lumps that I have to work with at 8:30 in the morning. Yes.
Maybe when the
I mean that very affectionately, of course, you know.
one method could be when you do like the proportions, like doing it more
Gabby's answering the question,
like
but you can't hear
over
her.
like 1 mole of NH3 over your 22.4 liters.
And you're reading right from the back of the book?
No, I did it already.
Oh, you did it? Okay.
And then you could just multiply that.
So you're getting very specific. You're getting very specific. May I help you?
Go ahead.
Is that okay? Permission to assist. Excellent. So in other words, you can either convert this to a mass and then do a mass, right? Or convert this to a volume, convert this to moles, and then do a volume and do a mass that way, right? Find out how many moles and then an equal number of moles, right? So how do you want to do it? You want to stick with the mole way?
Yeah.
Okay.
Yeah, the mole way. So how many moles does this represent? 15 liters. How many moles? How many moles? Remember, this is not a gas. This is not a gas problem. So what's going to be assumed? STP is going to be assumed, right? If it doesn't give you pressure, temperature, it doesn't give you all the measures for gases, then what has to be assumed? Otherwise you can't do the problem. And don't tell me on the answer sheet for your final not enough information. You're assuming, all right, so in other words, it's going to be, I'll work over here.
20,
Yes, you have it?
I think,
All right, how did you do it, Victoria?
15 divided by 16.
Well, yeah, but what did you do? You said what? You said 1 mole over what?
32.4.
Yeah, 22.4 liters equals X over 15, right? Isn't that what you said? Right? Okay, so solve for X. I mean, isn't that right? I'm asking you. I'm not trying to talk you into this. Okay, I want you to understand it. If you didn't do that, then do you get what I did?
0.67.
Now don't go crazy with significant figures. What did you say?
0.67.
0.67, that's good. So 0.67 moles, right? Is that right? So,
Wait,
go ahead.
that's when you divide 15 by 22.4.
1 times 15 divided by 22.4. You would actually be dividing 15 by 22.4. Thank you for the mathematical analysis. I appreciate that. It's always nice to have a color commentator when we're doing math. It does keep it interesting. I'm on the edge of my seat. I'm on the edge of my seat.
I don't even see the
Well, that's because I'm on the edge of it. I'm blocking it. Okay, good. Now, so if the number of moles is 1 to 1, isn't it?
Yeah.
So if this is 0.67, this is going to be 0.67, right?
Okay.
Yes? Is that right? Yes or no?
Yes.
Yes.
So how would you find the mass? If I say to you, there's 0.67 moles of lithium nitride, how would I find the mass? They're stunned. This is like, I know, this is, I'll say something in your favor, okay? Did you just slap your face to make sure you're awake? It was very good, excellent. Is that like a Belgian thing or? No? I mean, you really did slap your face. I was like, you did. It was very good. It was like you just put on aftershave or something. It was like, I like that. I like that. Very good, excellent. I will say something in your favor, and that is that it is June 8th, isn't it?
It is.
Yeah.
And it's 8:30 in the morning, and you don't like chemistry. How many people don't like chemistry? Now, there's 24 students in here. No, 23 students in here today. How many people don't like chemistry? Raise your hand. All right, so everybody, well, I'd say about 2/3 of the class is raising their hand. Yes, thank you very much, Will. I appreciate that. Mr. IB, excellent. I'm going to call your next year's IB teacher. Tell them that everybody raise their hand who's taking IB. Nobody raised their hand but you who's taking IB. Very good. He's raising his hand. He doesn't have to. That's how much he really wants to raise his hand. So what if I tell you that I have 0.67 moles of lithium nitride? What's the mass of 1 mole?
6.06.
No, that's the number of particles in a mole. You guys are really losing it. Look right here, 35, didn't we do this?
Yes.
Like 5 minutes ago, it seems like? So there's 35 grams in 1 mole of lithium nitride. But if I have 0.67 moles, how would I determine the number of grams in 0.67 moles of lithium nitride?
Proportion.
Say that 3 times fast. You could set up a proportional relationship, or you could just answer the question.
I like proportions.
Okay, well, that's fine. You can do the proportion in your head. Wouldn't you say, what's 0.67 of 35? Wouldn't you say that? You need to set up a proportional relationship. In New Jersey, we call that rabbit hunting. How do you catch a rabbit? You put salt on its tail and then you grab the rabbit. What's the moral of the story? No, leave the salt at home and just grab the rabbit. Okay? If you can do this by solving proportional relationships, just leave the proportional relationships at home and say 0.67 times 35.
23.45.
23.45. 23.45 grams. Is that what you're suggesting?
Yes.
Okay, excellent. Canadian team is back on the board going for the gold. Excellent. Okay, so I think that's C. That is 50. Shall I read the C again? That was a long problem, C. It says, calculate the number of grams of lithium nitride that must be added to an excess of water to produce 15 liters of ammonia gas. I converted 15 liters of ammonia gas to moles, 0.67. The mole ratio is 1 to 1. Therefore, I have 0.67 moles. 0.67 moles of lithium nitride, 0.67 moles. What's the mass of 1 mole? Well, it just so happens that the stoichiometric mass that I wrote above lithium nitride is the mass of 1 mole. So 0.67 times 35. The Canadian team got the points, and it is 23.45 grams. Excellent. Okay, we're off.